VPN Gateway versus ExpressRoute. Recently, I watched Frank Abagnale's talk on YouTube, and to be frank, I didn't know who he was or is. Now, if you're like me, you have also been living under a rock. He is essentially the real-life Leonardo DiCaprio of Catch Me If You Can. Anyway, between climbing out of this rock I've been living under and studying for the Azure Architecture certification, I started thinking about the connection between undercover agents and Azure networking, or more specifically, the commonly asked question about whether one should pick VPN Gateway or ExpressRoute to connect to Azure. As usual, I like to start with the basics before getting to the answer. So, what is VPN Gateway? Azure VPN Gateway allows you to connect your on-premises network to Azure networks to send encrypted traffic over an insecure channel. But what does that really mean? Let's say you have a bunch of servers on premises, which are just machines in some organization or some data center. And you want some of those machines to be able to connect and communicate with a bunch of Azure services, also known as cloud services. This is an example of site-to-site connection. We have one site, your on-premises, connecting to another site, your Azure environment. How does site-to-site connection work? Well, to enable site-to-site connection, or S2S, we need to install a VPN device into one of the on-premises network. This VPN device allows you to connect a VPN gateway, which you have to put into your Azure Virtual Network or Azure VNet. Technically, you have to carve out a section in your Azure Virtual Network, which is known as a subnet, called the Gateway subnet. This subnet needs to have enough space for the VPN gateway to use, so you need to use at least /27 for 32 addresses or /28 for 16 addresses for this gateway subnet. You also need to create a local network gateway, which is essentially a reflection of your VPN device that you have installed on premises. The local network gateway takes in the public IP address of your VPN device. Think of it as this is where your VPN device is located on premises. And the address space, which is essentially the number of address spaces you have in that particular on-premises network the VPN device is installed on. Now, remember what I said before about VPN Gateway allowing you to send secure traffic over an insecure channel? This is because the traffic gets encrypted before it is sent out, like Frank Abagnale putting on a disguise before he took on an undercover job for the FBI or committing a crime. When traffic is encrypted, you don't really know what type of traffic it is, nor the content of the traffic. Like when Frank was an undercover agent or committing fraud in disguise, you didn't really know it was Frank. You just know that it was some pilot, some doctor, or some lawyer, which meant the traffic can traverse over the internet, an insecure and public channel, freely, just like how Frank could roam about freely under disguise. Once we get to the destination, we can decrypt the traffic to reveal its contents, like removing a disguise to reveal Frank's true identity. To set up for encryption and decryption, the VPN device must share encryption and decryption keys with VPN Gateway. This is called shared key or symmetric key encryption. I won't go into details about encryption and decryption. Maybe it's a topic for another video. But essentially, the VPN device and VPN gateway share the same encryption and decryption keys, which means before the traffic is sent out to the internet, it is first encrypted. When either party receives the traffic, they can use the decryption key to decrypt the traffic. All you need to know for now is that VPN gateway supports IPsec/IKE protocols, which is the industry standard for cryptography when it comes to VPNs. Once your VPN device knows the shared secret keys to be used in information exchange, as well as the public IP address of the VPN gateway, you can create a connection between the two, and voila, you have connected your on-premises to Azure. VPN Gateway also supports what is called point-to-site or P2S connections. Point-to-site connections allows you to connect, say, your computer to your Azure Virtual Network. Again, the traffic goes over the public internet, but because it is encrypted, it remains anonymous, safe, and secure. Why would I use P2S connections? Well, let's say you have successfully set up the S2S connection between your organization's on-premises networks to Azure. Now, after all that hard work, your manager says, "Well done, you deserve a holiday," so you hop on the next flight out to Hawaii for a short vacation. As soon as you touch down at Inouye International Airport, you get a call from your manager. "Help," she starts to say, "one of our prod environment is down and we need you to fix it immediately." You roll your eyes and think, "I should really get a raise this year." But you don't say that. Instead, you tell her, "No worries, let me check into my hotel first so I can download the Azure VPN client to securely remote into Azure through VPN Gateway and fix it." P2S connection is really great for any remote workers that need to connect into your Azure VNets securely over the public internet. After your vacation in Hawaii, you come back to find that everyone is talking about ExpressRoute, and you start to wonder, what is Azure ExpressRoute? Azure ExpressRoute, your manager starts to say, allows us to physically connect our on-premises networks into Azure. Yeah, but why would we want to do that? Well, we don't want our traffic going over the internet anymore, and besides, we have been experiencing latency with more members joining the team, and we are getting internet outages. It's just a nightmare. Also, I overheard the CEO and the CTO the other day talking about expanding the office to the other side of the country, and sounds interesting enough, so you pull up Microsoft Docs to have a little read on the features and benefits of ExpressRoute. You find that to create an ExpressRoute connection, you first need to create a circuit. The physical connectivity into Azure is done by an ExpressRoute partner. So when you create a circuit, you are essentially asking your chosen ExpressRoute partner to set up a physical connection for you to connect to. They, on the other hand, connect the circuit into Azure. Once you've created the circuit, you need to extract the service key and pass that on to your chosen ExpressRoute partner. Once your ExpressRoute partner has connected you, you will see the provider status and your circuit change from not provisioned to provisioned. Now that you have your ExpressRoute circuits activated, you can start connecting your Azure virtual networks to your on-premises networks over ExpressRoute. Similar to VPN Gateway, you need to create an ExpressRoute gateway inside your virtual network before you can connect to the ExpressRoute circuit, like connecting to the VPN device. An ExpressRoute circuit can be connected to 10 different virtual networks, and a virtual network can be connected to 4 different ExpressRoute circuits. All traffic is now traversed over your own organization's networks and the Microsoft Azure networks, which means even if the public internet crashes, it will not affect your traffic flow. What happens when my ExpressRoute circuit goes down? Your traffic flow to and from Azure will obviously get cut off. So typically, to ensure for high availability, you have 2 ExpressRoute circuits set up, one as a primary link and one as a secondary or backup link. For disaster recovery, you can set up one circuit in one region and another circuit in another region. So even if the entire region or city goes down, your connection to Azure is not broken. And if you are really concerned, let's say you are worried that you might end up having a dispute with your ExpressRoute partner, you can set up multiple circuits across multiple regions with multiple different partners. And if all that fails, then we must have really hit strike on the doomsday clock.